Yeah. Section 3.2, complex numbers. Complex numbers. Check it out. So complex numbers are composed of all the stuff we've seen before. It used to be just real numbers, and that's broken down by rational numbers and irrational numbers. Rational numbers, then integers, whole numbers, natural numbers. Okay. And now we introduced a new thing called imaginary numbers. So imaginary numbers, imagine that. So imaginary numbers and real numbers come together to give you complex numbers. Okay, they come together to give you complex numbers. So the complex number is a plus bi, that's how it's written. This portion is the real portion of the complex number, and this portion is the imaginary portion of the complex number. That lowercase I represents the imaginary number. It's imaginary. Is someone imagined to use this? When was it used? Because the imaginary unit I, lowercase I, is defined as the square root of -1. So someone started using imaginary now. It was not John Lennon who did that. Sorry, side joke. When you get a negative inside a square root, now we can say it's no longer a real number, it's an imaginary number. When you have a square root number and you have a negative inside that. So one thing you do need to know is this stuff right here. 3 squared is 9, 4 squared is 16, 5 squared is 25. And the other way, the square root of 36 is 6, the square root of 49 is 7, and so on. This stuff you learned in 8th grade, this stuff you learned in Algebra 1, this stuff you should know. It's good to review if you don't have that stuff memorized. But all that stuff is good to know for this part of the class. Okay, so how do you solve these materials? Let's zoom in a bit here. These materials, how do we solve this stuff? So let's start off right here. So square root of -25. Hey, when you simplify the stuff inside the radical, you have a negative. So the first thing you want to do is take out that negative. So remember that -1, that's an I. So you want to take that out first, and we have this. I times the square root of 25. Take that negative out first. It's the first thing you do. Okay. Now, square root of 25. Do we know what the square root of 25 is? If only we had some place to know where the square root of 25. Square root of 25 is, let's use my calculator. It's 5. Okay. Now, so I times 5, normally it's not written that way. It's written the other way. It's written like this. 5I. That's your answer. Okay. Now, remember this right here. Are we taking the square root of both sides of an equation? No, so we do not have plus or minus. What about this one? Are we taking the square root of both sides of an equation? No, so you do not have a plus or minus. Okay, but you do have a negative inside that square root. So the first thing we do, get that negative, get that out there. That's an I. Take that negative outside, that's your I. It's equivalent of doing something like this. Square root of 1 times 20. Remember, I is equal to square root of -1. I, the same thing as square root of -1. So it's the same as this. And that is equivalent to this. So we take out the I, do that first. Now can we square root of 20? Square root of 20. 20 is in between here. So it's going to be someplace between 4 and 5. The square root of 20 is someplace between 4 and 5. We're not going to round this off to a decimal. We're going to get an exact value. So we have to do a factor tree. 5 times 4 is just that right there. This right here is prime. This right here, oh, that can be factored further. 2 times 2, that's prime, that's prime. So that can be written as I2. There's 1, there's 2 2's, and a 5. What we're looking for is a square root. We're looking for an identical pair. Identical pair. Here's an identical pair. Whoops. There is an identical pair. So you pull one of those 2's outside. That I is still outside. You have 5 is there. If we had 2 5's, we'd pull out 5's as well, but there's not, so you have that. And that cannot be simplified any further. This is your answer. Okay? When you take this and simplify it, you get doink, you get that. Okay? What about this? Oh, that's inside the radical. There's a negative. Let's pull that out first. Okay, pull out that negative from the inside the radical. Put out first, you get this. So square root of 7. 7 would be in here. Square root of 7 is someplace between 2 and 3. So we're going to write it as a decimal. In this case, we are not writing it as a decimal. We're writing it as an exact value. So 7, that's a prime number. So that cannot be simplified. Cannot be simplified. That is your answer. Next. Right here. Oh, look at that. We have inside the radical, we have a negative. So the 3 already exists outside. Let's take that negative, pull it outside, and do this. There. It's the first thing you do. Okay. Now, 12. 12. That's not a prime number, but we can do a factor tree. Let's see. 4 times 3 is 12. That's prime. That's not prime. Those are prime. So now we have 3i times the square root. We have a 2, we have a 2, and we have a 3. So there's an identical pair. So we have the 3 and the I. It's still outside. We have one of those 2's comes outside. We don't have you do not have an identical pair here, so that stays inside the radical. So it's not 3i2, it's 3 times I times 2. And that simplifies to 6i times the square root of 3. And this is our answer. What about this? Oh, that's very similar. Let's do this. I'm not going to make it that. We already got a negative 12 right there. Let's do that. There we go. 5 times the square root of negative 121. Okay. Let's take out that negative first. That negative comes outside. We have that I. The square root of 121. 121. It's not prime. That can be factored. It's 11 times 11. So now it's written as 5i 11 times 11. And we have an identical pair inside the radical. So that 5i still remains outside. We have an identical pair. One of those comes outside. And the only thing we have inside is just an invisible 1. So we really don't even need that. So 5 times I times 11 is 55i times the square root of 1, but don't waste your time with that. So just write it as, right here, 55i. Done. Fin. Okay. Wait, wow, what do we do here? What are we supposed to do here? Find the values. Find the values of x and y and what? Oh, this is a complex number. Complex number. It's in this form. Complex number. You have the real portion here, and then followed by the imaginary portion. It is not written as bi plus a. You do not write the imaginary part first and then followed by the report. Nope, not done. Okay, here's the real portion, here's the imaginary portion. Here's the real portion, there's the imaginary portion. So since they're equivalent, I know that because there's an equal sign there. Hey, well, I'm just going to take the real part and the real part, make those equivalent. Take the imaginary part and the imaginary part, make those equivalent. Look at that. So 4x equals 20. And solve. X equals 5. What about this part? Take the imaginary part and the imaginary part, set them equal to each other. Do that right here. 12i equals negative 3yi. Now this is going to throw some people off because, whoa, 2 variables, dude. What do you do with 2 variables, dude? Don't freak out. On both sides of the equation, you have the letter I. Get it? Aye, Captain. Aye. I get it. An eye for an eye makes the whole world blind. Huh? Hey, we can divide both sides by I. And now, when the i's cancel, we have 12 on both sides. The i's cancel here, we have negative 3y. I want to find the value of y, so we need to get this chunk to the other side of the equation. So divide both sides. This is negative 3 times y. You do not add 3 to both sides. It's negative 3 times y. So we divide both sides by negative 3. And when you do that, you get, that's a negative 4, and that's y. And to me, that's fine, but most teachers say, I want you to write the variable first, followed by the number. And this is your answer. So you found the value of x and y. Okay. What about right here? They're not using x and y, they're using different variables. But it's still, this is your complex number. This is your real part, followed by the imaginary part. The real part, followed by the imaginary part. And they're equivalent because there's an equal sign right there. So we take the real part, make it equal to the real part. 36 equals 72 q. Here's your q. So 72 needs to go on the other side of the equation. Divide both sides by 72. And q, q is equal to 1/2. Q equals 1/2. Now we have to find the imaginary part. The imaginary part is going to be equal to the other imaginary part. Set these two equal to each other. So we have negative 18 pi, negative 18 magnum, sorry, negative 18 pi. Lowercase I represents the imaginary unit. Okay, imaginary unit is I. Oh, put that away. This side is negative 36i. Okay, solves this. Yeah. Here's your I. Oh, both sides have the letter I. We can divide both sides. Well, the variable is going to be p. I'm going to divide both sides by I. And at the same time, divide both sides by negative 18. The i's cancel. I, Captain. What's remaining on that side of the equation? The letter P. P. And this side, negative divided by a negative is positive. 36 divided by 18 is 2. I divided by I cancels, and we get that. So Q equals 1/2, and P equals 2. Fin. Other side of them. Here we go. 6i. Ooh, we're going to add this stuff this time. Okay. Adds these materials. Ooh, it's so Here's a complex number plus another complex number. We're going to take the real portions and add them together. And then you take the imaginary portions and add them together. So it's 6 plus 7. And this is negative I plus a 3i. A negative I plus a 3i. So that would be a plus 2i. Done. This stuff pretty straightforward. Here we have, this is a real part. There is no imaginary in that. And then you have subtract the entire thing in the parentheses. Then you add 6i. So it'd be nicer if they actually did this. 7 plus 6i minus 3 plus 4i. They don't, but it'd be nice if they did that. So let's don't do that. It'd be nicer if they did, but they don't. So here is 7. Oh, it's distribute. That's a 7. Negative times a 3 is a negative 3. Negative times a 4i is a negative 4i. And that's just a plus 6i. So you're taking the real part, combining those. You're taking the imaginary part and combining those. 7 minus 3 is 4. A negative 4i plus 6i is plus 2i. And this is your answer. Fin. Okay. Imagine that. See you next time. Bye, guys.